Okay, so we're going to start learning how to name acids on page 13 of your packet, just page 13, and most of it is examples working out with you. So, honestly, this has a lot of information about what acids are and how they act, but we're going to spend an entire unit studying those later on. So specifically, what we need to know about our acids for this unit is that they're going to look like covalent molecules because they are made up of two nonmetals. But specifically, they're going to start with an H. So any formula that starts with an H is maybe covalent, but more specifically, it's going to act like an acid. And it's important that we name it like an acid so people know, oh my gosh, that's an acid. Kind of an important thing to know. But these acids are special types of covalent compounds because they have such a big electronegativity difference in their molecules that they're actually going to kind of act like ionic compounds. So when we're writing the formulas, we're actually going to be finding charges and cross-dropping and reducing, even though these are made up of two nonmetals. So it's going to be a little bit weird, but these are just special. So these are all of our rules for our three different types of acids. This first type of acid is what we call a binary acid. Binary just means two elements. So because it's an acid, our first element has to be H, and so we're just going to have one other element there. These other two types of acids, sometimes we call them oxy acids, but they're not binary. They're going to have three or more elements in their compound. So it's going to start with H, and then it's going to have one of those polyatomics that are on the back of the periodic table that we looked at today in class. So those are going to be this kind of second half of these compounds. So in binary acids, you're going to be able to recognize their names because their names start with hydro. You can see a couple examples here: hydrochloric acid, hydrosulfuric acid. And if you're looking at their formulas, the way you can tell whether or not to use hydro is that we're only going to use hydro at the front of it if it has no O's in it. It's just H and one other element. So hydro, some kind of root element name like chlorine, we added chlor here. And sulfur, we added that sulf bit here. And then at the end, we're going to have ic and then the word acid. So this is almost kind of formulaic when we're naming it. These are going to be hydro something ic acid. And this is only if we are a binary acid. So you just need to figure out what's that other element with hydrogen. If it's nitrogen, that's hydronitric acid. If it's iodine, it's hydroiodic acid. So just take the element that's there with hydrogen, the one other element, and stick the kind of root part of that name in here. Kind of like when we shortened it down to phosphide, and take that phos part, we're going to be adding ic to the end now instead of ide. Now, these other two types of acids are actually you're going to have to choose what ending to put on it. Some of them end in us, and some of them end in ic, like our binary acids. But the thing about these is if it does have oxygen in it, and it's one of those polyatomics with oxygen in it, we are not going to start with hydro. So we're going to jump straight into that root element like sulfur, and then add either us or ic to the end of it, depending on what polyatomic you have. And there's a trick. Notice over here it points out if the anion, if that polyatomic ends in ite, we're going to be using us. If the anion ends in ate, we're going to be changing the ending to ic. So I have a little saying, it's kind of ridiculous, but ic I ate a humongous bite. Doesn't make any sense, I know. A lot of the things that I remember from high school don't make sense, but they stuck in my mind, and I hope they stick in yours. But the ic version of our acids is going to come from the ate version of our polyatomic, and then the us version goes with the ite. So us and ite are together there. So, silly saying, but if it helps you remember which ending to put with which type of polyatomic, then you're good. So if we just look a little closer at these examples, you'll notice this sulfite is sulfurous acid. There's no hydro at the beginning because I do have O's in my formula, and I ended in us acid because it was the ite version. I have sulfate here, and it's almost the same name, still no hydro because I've got some O's in that formula, but this is sulfuric acid because the polyatomic ended in ate. So those are our 3 types of acids, and really what we need to do is some examples. But before we get into all of this, I have a few that I wanted to change just so that we get a good variety, and because there happen to be some repeats. And there's no use me working out the same problem multiple times because that's not helping you any. So I know this is kind of a weird table, but it kind of helps us break things down into the way that we need to think about these. So in this first row, all that I know is that whatever acid I have, the anion, the thing with the H, is I negative. Technically, we'd call that an iodide ion. Not super important, but that's just a single element. And when I'm putting that together in my formula, I'm going to be balancing out that charge with the H's. So just like when we were doing ionic compounds in class, I'm going to have my H at the beginning because I'm an acid, and then I have my I negative. Of course, that's a positive 1 and a negative 1. It's the only number we can leave off. And because those are both 1, my formula for this is HI. Now, writing my name is going to be a little bit more complicated, but I have to just think about that acid. First thing I have to decide, is it binary or does it have a polyatomic in it? And this one's just binary. So the first thing to start with when it's binary, when there's no O's in that acid, we start our name with hydro. And then all of these acids end the same way with the element name and then ic acid. So this is hydroiodic acid. That's it. All of these binary acids are going to end with ic. We don't have to make the decision about us or ite because I don't have any kind of ate over here. So I just realized that I've been writing all of that stuff out and I have it all nice and neat. So that's our first example. Now, what if I'm looking at the formula and I want to write the name? Well, even though I'm probably never going to ask you what the anion is, what you need to figure out is what is that thing in my acid other than the H. The H part isn't really the important part for naming. So when I'm looking at that PO4 part is a phosphate. And so if I'm trying to write this acid name, then I'm not going to start it with hydro because I've got some O's in my formula. Hydro is only when I have no O's. So I'm going to jump straight into the root element here, phosphorus, from that phosphate. And then I need to decide if it's going to end in ic or us. And ic goes with 8. So this is going to be phosphoric acid. Okay? Not too bad, I hope. Now, let's do another one where we're starting with that anion. So this is acetate, just, FYI. And remember, we're just balancing out the charge of H with this anion. And I know that just says negative there, but that's a -1. And so, just like that iodine, I just need one H to balance out that charge. Because, just quick note on this, all of my acids, are going to have hydrogen at the beginning with some kind of anion at the end. And I'm not sure what that charge is going to be, but every single time, hydrogen's charge is 1. So when we cross, drop, reduce, and bring that over, I'm never going to be bringing that 1 over, because I never write that 1. So really what I'm going to be focusing on is whatever the charge is of that anion that I'm working with is how many hydrogens I'm going to have in my acid. So both of the examples we've worked so far have our charge on that anion as 1. But pretty soon, like maybe down here when I see that sulfate, where it's not going to be 1. So we'll be ready for it when we get there. That charge is just going to be how many hydrogens we have. Now, let's name this. This is acetate that we were looking at in row 3, and it has O's in it, so I'm not starting with hydro. So I'm just going to start with acetate and then add on the ic acid ending, because ic goes with 8. Now, HNO3 is my acid. NO3 is nitrate. So once again, if I'm trying to write a name, 8 ending there means that I'm ending in ic acid. I've got a whole lot of those ic acids. Well, we'll get some practice with some other ones a little bit lower. But honestly, a lot of them do end in ic acid. I mean, that's a common response when you see an acid, right? Ic acid. But whatever. When in doubt, try ic acid. So, this is sulfate. And if we try writing our formula first, remember I have to balance out my H with that SO4 bit. So if I have an H plus 1, my SO4 has that -2 charge. When I cross drop reduce, then that's going to get me H2SO4. And the name of this is going to be sulfuric acid. Yet another 8 polyatomic, so it turns into ic. Well, what if I know the name and I need to find the formula? So this is chlorous acid. I'm looking at this name and I need to figure out what that thing with the H is going to be. What is my anion before I can even write the formula? So remember, chlorous, the us version goes with the ite version of the polyatomic. So I'm going to be looking on my polyatomic sheet for chlorite. And looking, found it. That's ClO2 with a -1 charge. Now I'm trying to balance that out with the H that's going to start off all of my acids, and once again that charge is -1, so I only need 1 H there. Hydronitric acid. Hydro means there's no O's in my acid, which means I'm not actually going to be looking at the back of my polyatomic sheet for a polyatomic. I just have some single element in that acid with the H, and the element is pretty obvious by the name. That's nitric acid. That's going to be nitrogen there. Technically, it's a nitride ion, but don't worry about that. It's nitrogen, and nitrogen always has the same charge, -3. So when I'm writing this formula for hydronitric acid, I'm going to have 3 H's and that 1 N. Balancing out those charges, just like we did with our ionic compounds, just kind of reminding you. Once you get those charges, cross, drop, reduce. Bring those over and down to get this formula. Let's do one more example, and then I'm going to leave the last 3 for you. So, H2C2CR2, O7. That's kind of crazy looking, but if I look on my polyatomic ion sheet for this CR2O7 stuff, I see that that's called dichromate. And even though that's kind of weird formula and it's kind of a weird name, the process is the same. We do not start the name with hydro because it's got some O's in there. I start with that dichrome part, and then the 8 changes to ic and makes it dichromic acid. So those are all of the formulas I'm going to do. I'd like you to try to finish these for your stamp. Now, I do say try. I don't need them to be perfect, but I'd really like to see you put some stuff down and see where you struggle, come with questions, because we're taking a quiz at the end of next class period over this stuff. There's not going to be a ton of acids on there. There are going to be some, and I want to help you next class period understand them and how to tell how and what to do on this quiz. So, come with questions, come to class ahead of time, and we'll go over this if you didn't understand it at all. I'll check your answers for you. I'll teach you whatever you want. Let's just make sure that we're ready for that quiz. Have a good rest of your night.